Okay, let's revisit our well-known set A, where A contains the elements 1, 2, and 3. We know how to compute the total number of subsets A has by using our notation of 2 to the power of n, where in this case, n is going to be the number of elements A has, which is going to be 3. So it's going to be really 2 to the power of 3, which is going to be 8. We know how to compute the number of subsets that A has when we're looking for the number of subsets with a specific size or a specific amount of elements. So for example, if we want to count how many subsets of A have 2 elements, we would say, well, these 3 have 2, so the answer is 3, and you would compute that by taking your total number of options, 3, and you want to choose 2 of them. So we're going to say 3, choose 2. Which is going to equal to 3 factorial over 2 factorial times 3 minus 1 factorial, which is really just going to equal to 3 times 2 times 1 over 2 times 1 times 1, because 3 minus 2 is going to be 1. So then you notice the 1 cancels, the 2 cancels, and you're just going to get 3 over 1, which is going to be 3. So yes, there are 3 subsets of A that have 2 elements. Well, now we're going to ask ourselves a bit of a different question. Now, instead of asking about the size of subsets or the total amount of subsets, we're asking how many of these subsets have a 2 in them. Well, if we look at all of the subsets of A, we can see that this subset has a 2 in it, this subset has a 2 in it, this subset has a 2 in it, and this subset has a 2 in it. But how would you know how many subsets of A have a 2 in them if you couldn't see all of the subsets? So in this case, we know the answer is going to, in fact, be equal to 4. But how would you do this if you have a really large set or a set that you simply don't want to spend the time writing this out? Well, I'm going to show you 2 methods. The first method is going to be using our 2 to the power of n notation, and the second method is going to be using our n choose k notation. Okay, so for the 2 to the power of n notation, our logic for 2 to the power of n was n is how many elements are going to be in our A. In this case, it was going to be 3 for the total. What if we fix one of our elements? In this case, we're saying, well, we have to have the 2. Well, in this case, we can then shrink our A. We can just say, okay, we went from A having 1, 2, 3, so you can picture it like saying, well, we have to have a 2, so we're going to pull a 2 out, and we're going to say A is now equal to 1 and 3. Well, now what do we know? Well, these are really the only things that can change, which means that instead of our n being 3, because A used to have 3, now A really only has 2 elements, right? 1 and 3. So we actually get 2 to the power of 2 is going to be how many subsets of A have the number 2. Because again, we are fixing the number 2. So we're kind of taking it out of this this box of potential things we can choose from. So we're now shrinking it to just 1 and 3. Count how many elements you have left. It's 2. 2 to the power of 2 is in fact going to be 4. That is how you can compute this using this notation. I don't like this notation because conceptually and logically it's kind of more difficult to understand, and mathematically this is very much incorrect. You can't just pull a 2 out and then count how many elements are left. That doesn't really coincide with reason. Okay, the second way of doing this is going to be to use our n choose k notation. N choose k. How are we going to do this? Well, we know that the total number of elements is going to be out of the 3 choosing 0, plus the number of ways out of the 3 to choose 1, plus out of all of the options we have, 3 to choose 2, plus all of the ways we have out of 3 to choose all of them. Okay, what do we know? Well, similarly to how we did with the 2 to the power of n method, we can fix the 2. So for example, if we go back to the example of the students and in the classroom that you can choose from, and you are the teacher, and you want to choose students, and you want to choose 2 students, you would originally say out of all of your 9 students, you can choose 2. But let's say that you, in fact, are going to definitely choose this student here. Now you only need 1 more student. So this wasn't really a choice, it's a fixed choice. You have to choose this student, and you want to choose 1 more student in your classroom. Well, now your choices go from 9, choose 2, they all of a sudden become 8, choose 1. It becomes 1 less, you have to make 1 less choice, and you have 1 less student to choose from. We're going to use very similar logic here. Because we are fixing one of the elements, in this case the 2, it's very similar to fixing one of the elements or one of the students here out of the 2 that you want to choose. So what we're in fact going to do is we're going to change the 3 up here, because out of all of our options, we can now only choose whether we're going to have 1 and a 3. So we're going to say, well, because we're fixing the 2, we can only choose 2 out of the elements now, right? Here, went from 9, now after we fix 1, we can only choose 8 now, because there's only 8 available students to choose from. We only have 2 elements to choose from. You can choose neither 1 and 3, so you can just have a 2. You can choose one of the 2 options. You can choose 2 and 1 or 2 and 3. That's what this means. 2 of the options, you choose one of them to pair with your 2. Or you can choose all of them, which is going to be 2 choose 2. So that's what this is going to look like. Imagine that we have a 2 here, and you can add to it nothing. Or you can add to it a 1, which is what this notation means. Or you can add to it a 3, which is what this notation means. Or you can add to it all, or you can add to them all of your remaining numbers, which is going to be 1 and 3. That's what this means here. So what our options are really going to be is the sum of all of these. These are your actual choices, because the 2 is no longer a choice. Your choice is whether you're going to choose whatever is left. You're going to choose none of it, 1 of it, or all of it. So what is this going to be? Well, 2 choose 0 is going to be 1, plus 2 choose 1. That's going to be 2, I'm thinking, but let's just verify that. That's going to be equal to 2 factorial over 1 factorial times 2 minus 1. Yeah, that's just going to be equal to 2, because 2 factorial over 1 is in fact just 2. So 1 plus 2, plus there's only one way to choose all of them, and that's going to be 1. And what do we find? 1 plus 2 plus 1 is going to be 4. Once again, what did we do? We said, okay, because you are fixing the 2, all you are asking yourself is, well, are you giving 2 a pair? If the answer is no, well, that's going to be 2 choose nothing. We're not giving 2 a pair. That's going to be like this up here. Next, you're going to ask yourself, well, what if we give 2 one pair? Well, that's going to be like looking at these 2 options. You're going to give 2 either a 1 or a 3. And finally, because we are already limited by the number of elements we have, which is 2, you can only choose 2 out of 2, so are you going to give 2 all of the pairs, which is going to be this bottom set down here. So this is how we can find in 3 different ways, kind of 3. I would really say 2, because you shouldn't write down all the subsets of something. This is how many ways you can find, or this is how many ways, not how many ways, I am so sorry, I am stuttering here. This is how many subsets of A have a 2, and I prefer, of course, the choose method.